Hi, myself Gautam Kumar came from Stankeshwar College of Engineering. Today I'm going to be explaining about analyzing a simple drawing patterns. Now let us look into the contents where what we'll be knowing from this video. First we'll start with the introduction, then we will move on to the overview of the drawing patterns, components of patterns, implementation, benefits of patterns, challenges and limitations, and real world application. Then we'll conclude. First let us look into the introduction. What are design patterns? Reusable resource solutions to common software design problems. Improvement software architecture by promoting best practices. Now let us see what is drawing patterns in focus. Patterns focus. Addressing how structure code for creating and managing visual elements such as shapes, lines, and drawings. Commonly used in graphical editing softwares, gaming designs, and CAD tools. Now let us see what is study. Why study a simple drawing pattern? Demonstrating a key principles like abstract and modularity and scalability helps in understanding complex patterns by breaking them into simpler components. Now let's look into the overview of a drawing pattern. A drawing pattern is a drawing pattern structure the code to represent manipulate graphical elements like shapes and group of shapes. Now let us look into the key concepts, that is providing unspecified interface for individual shapes and groups. Composition combines multiple objects like shapes to form a complex design. Error maintains parent-child relationship between shapes and groups. Use cases graphical design tool like ground objects in Adobe Illustrator, CADs systems for complex designing, game engineering for reducing scenes. Then code generating principles. We use mainly two things: reusability and scalability. Modularity of compounding different shape, harnessing both simple and complex composition streams. Now let us look into the components of patterns. Basic component, that is shape, type, abstract class or interfaces. Responsibility, which is defined as common operation like drawing, serves as a foundation for all other components. Next is leaf component. That example is triangle, circle, lines, responsibility. It represents individual graphical elements such as drawing method specifies each shapes. Now let's look into the composite components. Let it group types classes that implement shapes interface. Managing a collection of shapes objects left which combines both leaves and composites implements the drawing method using invoking draw on its children, enabling group and underlying shapes. Client code base using shapes interface to interact with both simpler shape and groups remains deoccupied from specific implementation. Now let us look into how to implementation, that is defining shape interface. The shape interface or abstract class is a core of pattern. It dedicates a method typically for drawing. That's all concentrated shapes will be implemented. This allows different shapes to be treated uniformly. Implementation implementing concentrated shape. Constraints such as circles, rectangles, and lines implement the shapes of interfaces. Each class provides its own implementations of drawing methods to render the specific object. The third one, creating a composite class group. A group class represents a collection of shapes, both like lines, circles, and rectangles. Other composite group, it manages the collection of shapes, detects the dedicates the call drawing to each individual shapes or groups within it using patterns in client code. Client code can now create various shapes, groups of shapes without needing to worry about the specific types. It interacts with shape interface calling drawing to any shape or group of shapes, making the code flexible and scalable. Now let us look into the benefits of patterns. There are mainly we'll be seeing about mainly four types: modularity, response, reusability, simplifying code maintenance, scalable and flexible. First one is modularity. The pattern encourages in creation of small and independent component shapes that can reduce cross reference path. Example, you can easily add a new shape like triangle or pentagon without altering the existing code. Simplification of code maintenance. Since the shapes are handling through common shape interfaces, Modifications are individual shapes cannot affect the rest of system. Example, adding a new method to a circle does not require changing in group or a class or other shapes. Scalability and function flexibility. The ability to group shapes allowing the system to handle both simple and complex drawing. You can nest a group within other group, forming, interacting, and hierarchical. Example, complex design like drawing houses can have groups of walls, windows, doors, etc. Now let us look into the challenges and limitations of drawing patterns. Complexity of large object hierarchies. As the number of shapes and groups increases, managing large hierarchy can become complex. Performance issue may arise while dealing with depending nesting groups or larger groups. Now let us look into the increased memory usage. Storing large number of shapes, especially a grouping containing multiple shapes, can lead to higher memory occupation. This is one of the drawbacks of increasing memory. Each shape or object can add up overall memory footprints. Limitations in flexible with shapes types. Where patterns are flexible, increasing certain advanced shapes may not fit near neatly into abstract. For example, shapes with complex 3D objects may require additional customization or new patterns. Now let us look into real world application. First one, graphical design software, that is Adobe Illustrator. Application, drawing patterns to widely used graphical design using managing complex drawings such as logos, illustrations, and vector arts. How it can help in designing to work in both simple shapes and complex depositions, providing a flexible and scalable way of managing renders. Next is game developing. Example is Unity and Unreal Engines. Example, game designs are used to draw patterns to handle and return both simple objects, characteristics, and more complex scenes. Grouping or logical scenes may level increase for game reality. Now let us look into another real world application, that is data visualization tool, that is D3 or JS using Django. That is data visualizing libraries tools using drawing patterns to create complex visualization for simple drawing points. Supports complex for multiple visual elements like lines, nodes, easily modify the graphical representations. Conclusion: the drawing patterns provide a flexible and scalable to maintain approach in managing and reducing graphical elements, often suitable, significantly benefiting modularity, reusability, abstract. It applies in real-world software such as graphical design, CAD system, game engines, demonstrating versatility of simplification, complex visualizing structures, while managing high performance. Dependency of some challenges may use in larger hierarchy using larger memories. Usage and pattern remains essential tool in model software development for graphical design.